All right, so let's talk about inverse functions in general first. If I want to find the inverse of y equals 2x plus 4, what do I do with the x and y first? What do you do with the inverse? You just switch them. Yeah, you switch x and y, you solve for y, right? Because when you find the inverse of a function, you are literally just exchanging x and y, right? That's an inverse in general. All right, so a little reminder here. A function has an inverse if and only if it is a one-to-one function. Okay, one-to-one function, remember that it means that it has to pass not only the vertical line test, but the horizontal line test. So think about a sine curve. Does the sine curve pass the vertical line test? Yes, it does, because it's a function. Does it pass the horizontal line test? No, it fails it miserably, right? So we can't just take sine as it is and switch x and y and have a zigzag thing going vertically, because it would not be a function. However, if the domain is restricted to a certain interval, the sine, cosine, and tangent functions have inverse functions. So we're going to restrict the domain, okay, and there's going to be a whole lot of domain restriction things going on in calculus. You just want to look at this one little section of whatever, and then you're going to do stuff with it, all right? That's what's happening here. So when graphed on a restricted interval, we do have inverses. And remember that we can talk about sine as sine inverse, but we can also say that the inverse of the sine function is the arcsine. Arcsine means the exact same thing as sine inverse. It is abbreviated as arcsine, that, or again, we could say sine inverse. Those are the exact same things, okay? The inverse of the cosine is the arc cosine, so abbreviated, it is ARC COS, or inverse cosine. And my board's being weird again, so it doesn't like me to do commas and other things. Inverse of the tangent function is the arc tangent. So we have arc tangent or tangent inverse. Alrighty, sound good? The same inverses as we talked about when you've done it before. All right, so we're going to look at sine first. So our arcsine or sine inverse, and we're going to do more than just a quick sketch of the parent function. We're going to graph it a little bit better than the quick sketches we usually do. We're going to go from negative 2 pi to 2 pi. So if I make this 2 pi, it makes this pi. And then you can do pi fourths and 3 pi halves. So negative 2 pi, pi, and then just chop those in half like that. So I know that for a sine function, I guess I should also have a 1 and a negative 1 here. For the sine function, at 0, it's 0, and it's also 0 at pi and at 2 pi. So that means we have it at negative pi and negative 2 pi. So at pi halves, I'm at 1, negative pi, 3 pi halves, I'm at negative 1. And here I'd be at negative 1 and positive 1. So I'm just going to make some points so I can make a semi-decent looking graph here to look at. It doesn't have to be perfect. Mine are a little off, but it'll be good enough to get an idea of what's happening here. Okay. All right. So clearly passes the vertical line test, completely fails the horizontal line test. What we need is a section of the graph that will take care of, because since it's a repetitive thing, take care of all of the y values, positive and negative. So if I start here and I go to pi halves, if I keep going past that, I'm just going to repeat the same y values I already had, right? I don't need to repeat them. Plus, if I keep going, I'm going to fail the horizontal line test, right? So if I go back this way to here and stop here, then that'll take care of my negative y values. But again, I can't go any farther because then I'll fail the horizontal line test. So this is the only section that we're going to actually use. It's going from negative pi halves to pi halves. And then this is your negative 1 and your positive 1. Okay. So we're going to restrict the domain. The domain for sine is all real numbers are negative infinity to infinity, but we're going to restrict the domain just to this part right here, that little curve. And that's what it's asking us to do right here. It says we're going to graph f of x equals sine x from negative pi halves to pi halves. So when my angle is negative pi halves, my sine value is negative 1. When my x value is 0, my angle is 0, my sine value is 0. When my angle is pi halves, my sine value is 1, and the section of the curve we have looks like that. Notice there's not arrows on the end, because that's where I stop. Like this has arrows because it would keep going, but that stops. It's the only parts we get. So our domain was given to us. It is negative pi halves to pi halves. The range is actually the same as it is for sine. It's negative 1 to 1. When you find the inverse of a function and you switch x and y, you also just switch the domain and range. So the range of this one, because we're going to do the arc sine now, the domain is what this range was. So it goes from negative 1 to 1, because those are now our x values. And our range is going to go from negative pi halves to pi halves. And notice on your graph that your x values no longer have pi's in them, but your y values do, because y is now your angle measures. Okay. So if I have a sine value of negative 1, my sine value is negative 1, what is the angle measure that goes along with that? See, negative 1, it would be negative pi halves. So if sine is negative 1, my angle is negative pi halves. It's also 3 pi halves, but in this graph, in the parts that we get to use, 3 pi halves isn't there, right? So, but another way to get there is negative pi halves. If my sine value is 0, my angle is 0. If my sine value is 1, my angle is pi halves. So these look almost identical, but they're not. It curves the other way because it is a reflection. So we get to use every sine value we have with a restricted number of angles, because there's an infinite number of angles that will give us those y values, right? But we don't have an infinite number of y values. Well, technically we do have an infinite number of y values, but so I want you to think unit circle wise. Yes, I know we have quadrants here. I don't really care about them so much, but unit circle wise, what quadrants are we using if we are going from negative pi halves to pi halves? What quadrants of the unit circle is that? Here's my circle. Oh, I'm using 2 quadrants, if that's what you mean. Do you mean quadrant 2, or I'm using 2 of them? What do you mean by that? You don't know what you meant by that? Okay. This is pi halves, right? This is negative pi halves, because I go this way, right? So if I'm going from negative pi halves to pi halves, I'm using quadrants 1 and quadrants 4 of the unit circle. Okay? And that's going to be important for us to tie to this. That's why we're looking at this like this. All right? The good news is you're not going to have to graph a whole lot of these. We're just trying to figure this stuff out by graphing it so you can see it. But we're using quadrants 1 and 4 when we're doing the inverses of sine. Let's look at cosine. So your arc cosine, there's this cosine inverse, and we're going to graph one of those two. So if I make that 2 pi, there's pi, then pi halves and 3 pi halves. Doesn't have to be perfect, but if you do halves, it's better than if you just try and do 4 of them out. Or at least for me, that's the case. All right, so the cosine of, this was off a little bit. The cosine of 0 is 1. At 2 pi, it's also 1. At pi, it's negative 1. And then I have zeros here and here. At pi halves and 3 pi halves. So doing the same thing over here. You don't necessarily have to make all these points, but if I don't, mine's going to look real bad, so it's a little bit better to It's not that hard to get them on there. It's not that big of a deal to graph it without graph paper. All right. So there's your cosine from negative 2 pi to 2 pi. So if we are looking at this, we can't, and I have to get a section of this where I can actually take the inverse. I can't go from negative pi halves to pi halves again because this part is going to fail the horizontal line test. I can still go from 0 to pi halves, but that only gives me half of my y values, but if I keep going to pi, then I'll be fine. This is the section of cosine we're going to use. It has to be different because of where things are positive and negative on these different functions. So I'm going to go from 0 to pi, this again being my negative 1 and my 1. So, and that's what we're told to do here, cosine between 0 and pi. So the cosine of 0 is 1. The cosine of pi halves is 0. And the cosine of pi is negative 1. So this is the section that I get so that it'll pass the vertical and horizontal line test. Again, no arrows because it's a restricted domain and I'm only looking at those parts right there. The domain here was given to me. I'm going from 0 to pi. The range is the same as it is for cosine and sine. I'm going from negative 1 to 1. So for the inverse, my domain goes from negative 1 to 1. My range goes from 0 to pi. So if my cosine value is negative 1, my angle is pi. If my cosine value is 0, my angle is pi halves. If my cosine value is 1, my angle is 0. So you got to know your values of the unit circle pretty well to be able to go backwards. And that's basically what the inverse is. And it looks like this. All right, so for cosine, if we're going from 0 to pi, which quadrants of the unit circle are we using? First and second, right? Because here's your circle. You're going from 0 to pi. That is these two. That is quadrants 1 and 2, not 1 and 4. Okay, because cosine's positive in the fourth quadrant, that's why we couldn't use this right here, right? We good so far? All right, let's look at tangent. So arctangent or tangent inverse Now, I don't have to go from negative 2 pi to 2 pi here because what is the period for a tangent parent function? Pi. So I'm only going to go to pi. So I got pi, pi halves, pi fourths, 3 pi fourths. So I'm still going to make 4 little lines, though. We're just splitting it up differently. And then I know for tangent, I'm going to have asymptotes at, so if this is pi, I have my asymptote at pi halves, right? Asymptote here at pi halves. And then 0 at pi fourths, I'm at 1. Negative pi fourths, I'm at negative 1. 3 pi fourths, I'm at negative 1. Pi, I'm at 1. So here's my parent function here. Enough of it anyway to figure things out. So if I want to be able to use all of the y values that I have, I can start here at 0 and go to pi halves. Now I could do what we were drawing as the parent function, and that would work. But if I can use the first and fourth like I did in sine and just kind of keep it continuous here, that's more what we're looking for. So this is what we have before we start repeating our y values. Okay, so we are going again from negative pi halves to pi halves. All right, so we know that when the angle is 0, the tangent of 0 is 0, tangent of pi fourths is 1, tangent of negative pi fourths is negative 1, and then at pi halves and negative pi halves, tangent is undefined, so we have asymptotes there. So that is what our tangent looks like. Our domain was given to us, negative pi halves to pi halves. Do I include them this time? No. They were brackets for sine and cosine, but at negative pi halves and pi halves I have asymptotes, so they're still important, but they're open. Okay. All right. So then my range, what's the range of this? Very good. Negative infinity to infinity. So then the inverse, I'm going to switch the domain and range. So our domain is now going to be negative infinity to infinity. And our range is going to be negative pi halves to pi halves. So if the tangent value is 0, the angle is 0. If the tangent value is 1, what is the angle? Pi fourths. Very good. And if the tangent value is negative 1, what is the y value, or what is the angle value? Negative pi fourths. Okay, and then what's happening at pi halves, at the y values of pi halves? Asymptotes. So I'm going to have asymptote here and here. Because remember, these are just reflections of each other in the line y equals x. Oh, that's really bad. Let me try that again. That is what your inverse looks like. If I am going from negative pi halves to pi halves, what quadrants of the unit circle, forget these quadrants, the quadrants of the unit circle am I using? First and fourth, because this is pi halves, this is negative pi halves. If I'm using these two right here, that's first and fourth. Okay? And that's what I wanted you to get out of this. I wanted you to see that you have to restrict the domain, because you're going to have to be restricting domains a lot in calculus. And what happens with the inverse, we're not really going to graph them so much, but we have to restrict them. So it's restricted when we answer questions whether we're graphing or not. You've got to remember that too. All right, so let's look at what we're going to do with this. We're going to redraw some stuff up here. So we've got arced, so we're going to start with arc sine. Right? And arc sine, or sine, we know is positive in the first quadrant. It's also positive in the second quadrant, right? That's why we have to use the fourth quadrant, and why we're going from negative pi halves to pi halves. Okay? So arc cosine, everything's positive in the first quadrant, but cosine's also positive in the fourth quadrant. So we have to use the second quadrant to get our values. We are going from 0 to pi. For arctangent, everything's positive in the first quadrant. Tangent is actually positive in the second, negative in the second and the fourth, but we are using the fourth quadrant. which means for tangent, we're going from negative pi halves to pi halves. So this is us going backwards. Usually I stand at the door and I say, what is the sine of pi 6? Right? And you can go, right, pi 6, the sine of pi 6 is 1/2. Instead, I'm going to say, what is the arc sine of 1/2? Meaning, if you have a value of 1/2, what is your angle measure? And you can still use the hand trick to figure that out. Does that make sense? I'm giving you the answer and you're giving me the question. Basically, it's the reverse of what we had been doing. You will be able to give, so we're using these two here, using these two here, these two here. So your answers for arc sine and arc tangent, or sine inverse and tangent inverse, could be positive or negative. Notice for cosine, you're not giving any negative angles at all. Okay? We also have, so let's do a few and then I want to take you down one other road here. Let's look at this. The arc sine of 1, meaning if you have the sine, if your sine value is 1, what is the angle measure? Pi halves. Does that make sense? Because if I said, what is the sine of pi halves, your answer would be 1. So the arc sine of 1 is pi halves. We're just going in the opposite direction. So again, you got to know your unit circle. If you don't, this is going to be impossible for you. The sine inverse of the square root of 3 over 2. So again, you can use the hand. So here, to make sine square root of 3 over 2, it would look like this. So what is this angle? Pi thirds. So the sine inverse of the square root of 3 over 2 is pi thirds, because the sine of pi thirds is the square root of 3 over 2. Just going in the other direction. It's like doing division instead of multiplication. The arc sine of negative 2. If you have a sine value of negative 2, what's your angle? Can you have a sine value of negative 2? What's the smallest sine value you can have? Negative 1 is the smallest sine value you can have, right? You can only go from negative 1 to 1. So can I take the sine inverse of negative 2? No, that's why when we were doing the laws of sines and cosines and you would do the sine inverse of something, it would give you an error. It's because you were trying to take the sine inverse of like 1.4 or something like that, and so your triangle didn't work because you can't do that. So same thing here. You can't. It does not exist. All right, cosine inverse of negative square root of 2 over 2. Me personally, I like to think of them all positively first. Okay, so I can think, all right, if I have the square root of 2 over 2, that means that the angle measure, if I'm using cosine, is going to be pi fourths, right? But this is a negative square root of 2 over 2. And for cosine, I only get to use first and second quadrants. So since it's a negative value, it's my second quadrant pi fourths angle, which is 3 pi fourths. And then you can always check yourself very easily by saying, what is the cosine of 3 pi fourths? Oh, guess what? It's negative square root of 2 over 2. Okay? We good? All right. Cosine inverse of 3. What's the largest cosine value you can have for any angle? 1. So what's the answer here? Does not exist. Right? Arc cosine of negative 1. If you have a cosine value of negative 1, what is the angle? Pi. All right. So, like I said, I'm going to take you down another road here real quick. If I say, if we take the sine of 7 pi 6, not the sine inverse, the sine, just straight up sine of 7 pi 6. First of all, what quadrant is 7 pi 6 in? Third. So is sine going to be positive or negative? Negative. All right. So then what is the sine of pi 6? 1/2. So that means my answer here is negative 1/2. We all agree with that? That's all business, right? But here's something that you have to understand. The sine inverse of negative 1/2 does not equal 7 pi 6. So although 2 times 3 is 6, and 6 divided by 3 is 2, and you can do that all day long with multiplication and division, it doesn't work that way here just by going straight up backwards. You're not necessarily going to get the answer you got before, because this angle is in the third quadrant. Am I allowed to give answers that are in the third quadrant? No, I can only give answers that are in the first and the fourth quadrant, right? And if my sine value is negative, would I be in the first or the fourth quadrant? Which one? Fourth. If the sine is negative, I'm in the fourth quadrant. So that means that the sine inverse of negative 1/2 actually equals, and even though I'm in the fourth quadrant, it's not 11 pi 6 because I can only go from negative pi halves to pi halves. It would be negative pi 6. There are an infinite amount of angles that I can take the sine of and get negative 1/2. Okay, but when I'm taking the inverse, there's only one answer because I'm restricted now. Okay, we weren't restricted before, we're restricted now. The answers that you give to inverses can only come from specific quadrants. Okay? Now, it's true that the sine of 7 pi 6 is negative 1/2. We weren't wrong about that. But when you're doing the inverse, you're restricted now. Okay? And then we'll get to how you look at those other answers. All right, so let's look at the arctangent of square root of 3 over 3. If I have a tangent value of square root of 3 over 3, what angle did that come from? Pi 6. Very good. But again, you got to know your unit circle values or this is impossible. Arctangent of negative 1. So it's a negative value, and tangent, we use which quadrants for the inverse? First and fourth, okay? So you can think positively first, like what is the arctangent of 1? Pi fourths. But since it's a negative 1, I have to go the negative way, and it's negative pi fourths. So it's easy to figure out the negative 1. It's not like you have to figure out the fourth quadrant angle. You just put a negative in front of it. Tangent inverse of the square root of 3. What angle would that be? Pi thirds. Because the tangent of pi thirds is the square root of 3. All right. Arc cosine of square root of 3 over 2. So you can use your hand trick. This is how I make the cosine square root of 3 over 2. This angle is pi sixths. But this is a negative value. For cosine, which quadrants are we using? First and second. So if I know that my answer, it's a pi sixth angle, I just have to come up with my second quadrant pi sixth angle, which is what? 5 pi 6. You will not give a negative angle for cosine, for arc cosine, okay, because you're using quadrants 1 and 2. All right, tangent of 1. What would that angle be? Pi fourths. Anytime you have a positive value, it's going to be a first quadrant angle for all of these. All right, so now I have arc sine of the negative square root of 2 over 2. So just sine, if I have a sine value of square root of 2 over 2, my angle is pi fourths, right? But this is negative, and so the negative for sine inverse comes from which quadrant? The fourth quadrant, and I have to use the negative angle to get there, so it's negative pi fourths. Okay? Does it make it a little bit more sense now? This is something that takes practice, okay? So you got to kind of wrap your mind around it, and then you got to practice and think through them. If you know your unit circle values, you can totally do this. You just have to think an extra step, and at first you have to think a little harder, but then it gets a lot easier. All right, so I'm going to give you a second. I want you to do 13, 14, and 15 on your own. Okay, so for 13, sine inverse of 1/2. So if I use my hand trick, here's how I make sine 1/2. That means the angle is pi sixths, but this is a negative 1/2, so that means my answer is a negative pi 6. Everybody good with that? Arc cosine of 2. Can I have a cosine value of 2? No, so this does not exist. All right, arc tangent of the square root of 3. Well, if I have a tangent value of the square root of 3, that angle is pi thirds, but this is a negative square root of 3, so this is a negative pi thirds, because I got to go down to the fourth quadrant. We okay with that? All right, you do these next 3. Okay, let's talk through these. I have sine inverse of 1/2. That's positive, so I know it's coming from the first quadrant. Again, I can do my hand trick. It's pi/6. Arctangent of negative square root of 3 over 3. Well, if I have a tangent value of the square root of 3 over 3, that's pi/6. But this is negative, and it's tangent, so I have to go down to the fourth quadrant. That makes it negative pi/6. Cosine inverse of negative 1/2. Well, here's on my hand how I make cosine 1/2. So that means it's a pi/3 angle. Cosine, I'm not going to have a negative angle no matter what. So my pi/3 angle has to come from the second quadrant, and that is 2 pi/3. What questions do you have? Anything? Okay, so we're actually going to skip the rest of this because this is an application about like when you would actually use this, but I would rather you have time to work on this. So I want to show you, your assignment is informative. I don't have a worksheet that goes along with it for you this time. You'll be able to see them and you can enlarge this part right here. I can't do that from where I am. You can click on Zoom. Well, I guess I could. You can click on Zoom in right there and then you can see it. And then I'm afraid to, I don't want to get out of previewing as a student. Dang it! I wanted to show you one more thing. Now I don't know what it did, but maybe if I can go. Oh, okay, good. Whew. All right. So when you're here and you're typing it in, when you have to do the pi, don't copy and paste from anywhere. It does not like copying and pasting. You hit this little keyboard right here, and you use this pi. I think when y'all have hit the keyboard before, there was like a blue box right here that said new keyboard or something like that. On my view, I don't see that anymore, so maybe they did away with that, because I think that's where some of you were getting into, like, it wasn't liking what you were typing in. If you get a keyboard that takes up, like, the whole bottom down here, you need to back up and get out of that. You need to use this one. Remember, if we hit pi and then we have to divide by something, you got to click back up here so that you can do, and then you can use your keyboard for the rest of it. Okay, does that make sense? Because I don't want you to get frustrated and get in the cycle just because it isn't liking how you're typing things in. I have it set to where it will show you the, whether you're right or wrong instantly. Okay, so you'll know as you're going. But I think you'll feel yourself as you go through this a little bit more confident as you're going through them. Okay? Any questions at all? Awesome.